Hi, everybody. This is Rich Mintz, Product Marketing Manager for Abaco Systems. I'm joined today by Pete Thompson, Vice President of Product Management, to talk about the Sensor Open Systems Architecture, or SOSA, and how it leverages the OpenVPX standards. Pete, thanks for joining us today. Take it away.
Thanks, Rich. We're going to talk about SOSA and how that leverages OpenVPX standards, a little bit about how that factors into interoperability in different types of applications of systems, and also how it factors into the roadmap here at Abaco. So one of the issues we face as a board and system vendor is that we not only need to follow new open architecture mandates like SOSA. So in a lot of cases, that means we have to develop two versions of a product, one that is going to be aligned with the SOSA technical standard, and also one that our existing customers use to refresh their existing designs. That may be to address things like obsolescence or to add new functionality into a system. When you consider that we have 4 product streams here at Abaco, and currently we have 16 or maybe even more 3U and 6U VPX products, get a real problem. And just to highlight some of the differences between those different product lines, they have different profiles to the backplane, they have different power supply systems, and the system management is different, so they can wind up being quite different designs. The other thing we have to factor in is that SOSA is not a ratified standard yet, so we still need to develop products, but we need to acknowledge that the standard may change between now and when it becomes ratified.
So Pete, I wonder how many of the viewers may be wondering, so is everything moving to SOSA? I mean, it sounds like everything is kind of being designed in that way. So can you help us understand how that's not necessarily the case?
Yeah, that's a great question, and that kind of is illustrated in the slide here. In the migration towards a mix of SOSA and legacy products over time. Certainly we see a drive towards a world that's going to be dominated by SOSA aligned products, but there's always going to be reasons why you may not want to do that. Maybe you need to do those technology insertions that we already talked about. Maybe SOSA doesn't give you the best solution in terms of size, weight, and power, and you need to do something different. So there will still be a need for non-SOSA aligned products as we go forward. So to bring that round to where we are in terms of our roadmap, and this is a illustration. You shouldn't take this as being the gospel in terms of what's going to happen and when, but the real takeaway from this is the movement from 2019, when we had no SOSA aligned products, through to today, when we're starting to introduce our first SOSA aligned products, and going forward, you can see the number of SOSA aligned products starting to dominate the roadmap.
So Pete, you and I have spoken about how SOSA is still an evolving standard, and I know there are some older but still current VPX products on the market that some may say they meet older snapshots or even the current snapshot of the standard. Abaco's chosen not to call those older products aligned since the standard's still evolving. Can you share some thoughts on that?
Yeah, so for instance, if you take a look at on the roadmap here, the existing SBC 329 and SBC 347D products, those do actually align with the backplane profile, the backplane legacy profile that is currently in the SOSA Snapshot 3. They don't fully meet the SOSA mandate in terms of not using 5 volt or 3.3 volt power supplies, for instance, and not having the correct scheme for system management on the board. And also, we expect that legacy profile to be deprecated from the standard at some point. So, we've decided not to say those are SOSA aligned for the technical reasons, and we're preferring to design alignment to SOSA by design and not by chance, which those were products that were designed before SOSA was a thing. So moving on, Once we've decided what we think our product portfolio is going to look like in those roadmaps, and that's again, a mix of tech insert and SOSA line products. And one thing we like to do is tie those portfolios back to their actual use in a real world system. The reason there being that we want to make sure we have a rounded ecosystem that can support those different applications that our customers are going to be using our products in. So this is an example of how we do that. We call it our sensor to action mapping, and this one happens to be a 6UVPX system, and it's a notional representation of an EW system. It doesn't represent anything in reality, but it gives you a sense of the functional blocks that are required in that type of a system, and which of our boards fit into that. So it allows us to make sure we're investing in the right product areas, making sure we're doing the right OpenVPX and or SOSA profiles. And this is just another example of the same thing, but in the 3UVPX world, and this one is a notional radar processing system. So you can again see how we map our products that are either in existence, or if we have a gap in here functionally, maybe we look to do a new product in the future that's going to fill that gap for our customers.
Some of our viewers may be thinking that all SOSA products are identical. I mean, all suppliers use the same silicon. VPX dictates dimensions, and SOSA requires electrical uniformity like pinouts and power. So other than price and availability, how is the user supposed to determine the best product for the application?
That's really a great question. So as you say, Rich, one of the things that SOSA does is tie down both the electrical and the mechanical parameters of boards that go into a system. And what we see here on the left is a SOSA, I believe it's the IO intensive profile, that was then fed back into OpenVPX to be ratified as an OpenVPX standard. And one of the differences there is before SOSA, the bottom connector you see there, the P2, would be open for any vendor to define whatever they want on those. So that's okay for us as a vendor, but it gives our integration customers a headache in terms of every time you have a difference in those pins on any of those connectors, you may wind up having to respin a backplane if you have to change a board in the system from one vendor to another, or from one generation of a product to another. So it ties down all of those pins and their definitions to the backplane. So everybody's board winds up looking the same from the outside, and on the inside, as you kind of alluded to, we're all designing from the same pool of silicon devices from manufacturers, and those devices themselves are becoming more and more integrated as systems on chips, which takes away any flexibility you might have had in the past in terms of putting external peripheral devices around the processing, whether it's that applies both to FPGAs and to general purpose processors. So again, the architectures of boards start to look the same from different vendors, and so we look to find ways of differentiating ourselves from other vendors in the same space. So obviously part of it comes down to price, but that's not the only factor. A lot of it comes down to value, and so we'll look at ways that we can increase our value to our integration partners for our tool chain, our access tool chain, to give our customers tools that help them to accelerate their time of development of their software for the application. And time is money, so any time we can help them shave off their development cycle, this is obviously going to reduce their costs. We also invest a lot in our cooling technologies, both at the board and system level. And the way that translates to value is because some of those current day system on chips have very high power consumption, you can wind up very often in a case where you cannot extract all the heat from the device if it's running at full speed. And that means you may have to reduce the clock speed of your device, which means you're not getting the full performance that you paid for from that device. So by taking an end-to-end approach and then applying some innovative cooling technologies, both at the board and at the system level, we help to get the heat out of the system effectively, and in a lot of cases we can wind up maintaining, running those CPUs and FPGAs at full clock rate, whereas somebody who doesn't have equivalent thermal technologies may have to again force the end user to reduce the clock rates and reduce performance. And the final factor that we think comes into play a lot, and will increasingly do so, is building security into our solutions. And this doesn't just apply to the mil-aero domain, and anybody even in the industrial space now is interested in how they can protect their systems, so that's making sure that they're not being hacked from either a hardware or a software point of view to extract whatever may be of value in the system. And one of the things you learn very quickly once you start to look at how you can implement security, it's not something that you can bolt on as an afterthought. It has to be an integral part of the design from the very start. And so as you'll see as we look at some real-world products coming up, we've done a lot of work to make sure we support our customers in being able to implement that security, both in terms of protecting the boot, and that means making sure that your operating system and your application is not being tampered with in any way before you boot, and also being able to monitor things in real time at runtime to make sure that things are operating as they should be. So moving on here to SPC 3511, this is a product we're pretty excited about. It's our first product that we brought to market that is aligned with the SOSA technical standard. It's in full production now, so you can go to your Abaco sales guy and procure one of these today. It's based on the I/O intensive profile for 3U boards, and it's based on the latest generation of embedded Intel 6-core CPU combined with a ultra-scale FPGA from Xilinx that's there as the security hub to help us implement that level of security that we just talked about. Why is SOSA important to us and to our customer base? Well, really that's kind of illustrated on the right-hand side here in terms of accelerated change and updates, and that's kind of driven by that convergence of those pinouts to the backplane. Reducing that variability there means that you can design for technology insertion and plugging in different boards from different vendors, and even to the extent of being able to take out, in some cases we've seen, take out an FPGA board and put it in a CPU board in the same slot, and that drives into improved life cycle and supportability, because some of these systems have to be out in the field for 20-30 years and be maintained. And again, that convergence drives towards interoperability between boards, and again that reduces the cost of putting systems together and maintaining those systems. And that all comes around full circle to lowering the total cost of ownership, and that's obviously of interest to all of us as taxpayers.
Pete, thanks for joining us today. It was a really good presentation and a lot of information on SOSA and how it affects the roadmap that Abaco is putting together and how our customers can interface with that in their applications. For our viewers, we appreciate your time today. You can find more information at abaco.com/SOSA. That's abaco.com/SOSA. Thanks a lot for joining us. My name is Rich Mintz with Abaco Systems, and we'll see you next time.